Welcome. Today we'll find the inverse of the function f of x equals negative 2x divided by x minus 1 and verify our result. To find the inverse function, we'll follow these steps. First, replace f of x with y. Then swap x and y. Finally, solve for y to get the inverse function. Let's start by replacing f of x with y. This gives us y equals negative 2x divided by x minus 1. Next, we swap x and y. Now we have x equals negative 2, y divided by y minus 1. Now comes the algebraic work to solve for y. First, multiply both sides by y minus 1. This gives us x times y minus 1 equals negative 2y. Distribute x on the left side to get x, y minus x equals negative 2y. Combine like terms by moving all y terms to one side. We get x, y plus 2y equals x. Factor out y to get y times x plus 2 equals x. Finally, divide both sides by x plus 2 to get y equals x divided by x plus 2. Therefore, the inverse function f inverse of x equals x divided by x plus 2. Let's verify this is correct by checking that f of f inverse of x equals x. To verify, we'll substitute f inverse of x into our original function f of x. Let's take f of x equals negative 2x over x minus 1 and replace x with x over x plus 2. This gives us negative 2 times x over x plus 2 divided by x over x plus 2 minus 1. To subtract fractions, we need a common denominator. Multiply the 1 by x plus 2 over x plus 2. Now we can subtract the numerators x over x plus 2 minus x plus 2 over x plus 2 equals negative x minus 2 over x plus 2. Our fraction becomes negative 2x over negative x minus 2, which simplifies to x. Therefore, f of f inverse of x equals x, verifying that we found the correct inverse function. Let's summarize what we learned. To find the inverse of a rational function, first, replace f of x with y. Then swap x and y. Finally, solve for y using algebra. Always verify your answer by checking that f of f inverse of x equals x.